Hello, everyone. Later today, I think we're going to first review this solution that we have devised the day before yesterday, and see if how we can improve it a little bit. And later, I would like to walk through the basic syntax, which I should have walked through so much earlier. So yeah, if we still have some time, and I believe we are going to have some time for this. We're definitely going to have some time for this. So let's get started. So first of all, let's take a look at the common character count, which is the which takes two strings as the input and counts how many common characters does it have. So what is this? Oh, so yeah. So, let's get it started with. I think we need to have some constant here. We want a value which is of the length. I don't know what's the preferred best practice for Kotlin constants, because in Java the constants are all caps and divided by underscore. But yeah, I think I'm going to take a look at it directly. Kotlin, all caps. Coding conventions, yes. All caps. So choosing good names. Yeah, wow, this is actually pretty good. If there is such thing. This is the name of the class, and this is just as how we do in Java. Capital, the first capital, capital, the first. Oh, this is interesting. I don't know if it consists of two letters. We should capitalize both of them. Yeah. This is interesting. So, I don't think there is a all caps constant coding style convention in Kotlin, so we're going to just simply call it length of what? Of English letters, and that can be, yeah, I think that's the length. No, this should be 0 if it is its length. So maybe this way. Initialize lm2, and this naming is also actually imperfect. What's array1? It actually should be the dictionary size no character to count dictionary. Let's just call it map. Although it's an array, but I am using it as a map. And character might say this actually should be the function, but whatever. I don't think that should be improved. So yeah, that's how I would like to improve for now. Character why is it looking like this? Why is there such character? Okay. Really? How is this used? Where did we start from? Oh, there it is. So yeah, this is not used at all. So let's move on to the basic syntax. Nice. So for defining packages, it's just like Java at the first line and import whatever they want. So defining functions, we have already talked about this earlier in the episode 1. If you haven't looked at it, you can look at it now or after this session, whichever you like. So and function with an expression body and inferred return type. Okay, this is a syntax sugar, so I am not going to use it until I'm really familiar with it. But yeah, because a plus b is implied to be integer, so with these return type, we can skip this return, and we can also skip this definition here. This is all it is trying to say. And what's this unit here? Unit, I think it's sort of working like void. Yeah, returning no meaningful value, that would be unit. The unit return type can be omitted, so we can just do nothing and it is returning unit. For defining variables, val is the keyword that can only be assigned once, which is to me pronounced as value, and var is variable, and it can be reassigned. And I'm also actually pretty interested in these properties and fields. So let's take a look now. Value and var are all properties of a class, is it? But these are in function scope, so how can they be value var? But well, it does not actually mean something, I guess. Yeah, use a property, we simply refer to it by name as if it were a field in Java. So the result equals to address. There's no new keyword in Kotlin, I know. And assessor. So for these properties, we directly use it. We don't need to as if it were a field. Yeah. So this property is it's something work like field, but it has auto-generated getters and setters. And if you don't want it, okay, var are var and val. I'm not sure if val is a property at all, because val is not modifiable. I'm not sure about that, but because yeah, it's demonstrating a property with only var, but no. Oh, here's val. So maybe val. There's a val style property. So var property name. This is here used here, and the property type. This can be skipped if it can be inferred. And there is an initializer behind this equal. Well, yeah, that's simple too. And we can have getter and setter in the next line, next two lines. That's default getter and setter implied. Arrow explicit initializer required because there is no initial, it is not initialized. And via val simple, and it must be initialized in constructor. Okay, cool. So for a value, it should be initialized and when it is declared, or when it is in constructor. Read-only property. So this is a read-only property val, and var is a normal property. It's not it does not have a special name here. So we can this time consider. So get is empty. This is because it is not initialized, but it is okay. Set get. We can give it a get, but if we don't give it a set, then it will not be. It will not have a setter, I guess, or has a I don't know. Does val have a setter? I don't think so. Custom accessors for a property. Custom getter, it will be called every time we access a property. Yeah, this is a computed property. It maps. It's actually working like the function is empty, but it's a property. That's something we can do in Java. If we define a custom setter, it will be called every time when we assign value to a property. Custom setter looks like this. So yeah, we can parse it. Name of the setter value parameter is value. Okay. You can omit the property type if it can be inferred from the getter. Okay. This is yet another syntax trigger. If you need to change the visibility of an accessor or to annotate it, but don't need to change the default implementation, you can without defining its body. There is no brackets here, so yeah, make it private or annotated. Cool, that's cool. Backing fields. Are we going to read all these? Maybe. Fields cannot be declared in Kotlin classes. However, when the property needs a backing field, Kotlin provides it automatically. Backing field can be referenced in the access using the field identifier. Okay, so these properties are actually backed by fields, Java fields, and where can only be used in the accessors of the property. So this means the integer which is backing this field. Yeah, so we're not writing if value is larger than 0 counter equals to value, because that is kinda misleading, I guess. So we use field equals to value here. So with list setter, we only take values that are larger than or equals to 0. Like this is the one that we look at. Backing field will be written for a part if it uses the default implementation of at least one of the accessors, or so yeah, it is generated only when there is a getter or a setter. If a custom accessor reference it through the field identifier, or you have customized the getter and the setter and it has field in it, like this one. Backing properties. What is this? So you can have a backing properties yourself rather than you can have a backing properties rather than backing fields. Like in this example, there's a private var that is underscore table, and it is default to be null. And if it is null, it is initialized. So whenever we get the table, it is always initialized, and so this is set to null in the other thread. Yeah, I'm going to skip this. Compile time constants. properties the value of which is known at compile time can be marked as compile time constants using const modifier. So yeah, and here's the coding convention that I have talked about. It's all caps, const value. So I think the nice part that we can have for constant value is performance, I guess. And there is also late initialized properties and variables. Normally, properties declared as having a non-null type must be initialized in a constructor. Okay. This is not convenient, of course. For example, properties can be initialized through dependency injection or in yes, of course. In this case, you cannot supply a non-null initializer in a constructor. So if we annotate, is this annotate modify? Use the late init modifier to against a variable, then it can be where's the constructor? Well, there is no constructor in this case, but it is not initialized in a constructor, but it is initialized in this setup. So it is still initialized, but if you want to initialize after a constructor call, then you will need this late init keyword. So we can also check if a late init variable is initialized. I'm not going to go into these overriding properties and the delegated properties is something fun, I guess, but let's take a look at these lines only. The most common kind of property simply reads from and maybe writes to a backing field. On the other hand, with custom getters and setters, one can implement any behavior of a property somewhere in between. There are certain common patterns of how a property may work. Lazy values, reading from a map by a given key. Well, let's just only pick at it. That's a lot, and I think it's a little bit advanced. Yeah, it's a little bit advanced, so let's not look at it today. Yeah, and we have already read this some part of these partially the coding conventions. Let's move on with defining variables. Yeah, we have read this property and fields and comment. It's same as Java. There is a single line and block end of line comment. And this is interesting. I have never tried this. Block comments in Kotlin can be nested, so you can have a if you can block this part and it will not end here. It will end here instead. String templates. What's a string template? Oh yeah, of course. A is a variable, so a equals to 2. So if we replace s1 here, dot replace is to was, then this whole thing would be let's take a look at it. A s1 dot replace is to was, and it reference value a. Oh, this is pretty much like scripting, shell scripting, I guess. A equals to 1, and but now is why? Oh, okay. So this is compiled here at this time. So this is unfolded into 1, and at this time it is not. This is not a string style reference. It is only unfolding once when it is constructed. So yeah, this one is a is 1, and we replace the is in it to was, so it becomes a was 1 and comma, but now is, and we reference a again, which now is 2. Using conditional expressions, if of course, know this. So this is kind of like the Elvis operator in Kotlin, in Java. It's the question mark. Where can I see that Elvis operator? It's a question mark. Where is it? Can't find it. Oh, here. No example here. I need an example here. Oh, actually it's not Elvis operator. Is it? No, it's not Elvis operator. Ternary operator. Yeah. In Java, that's the ternary operator. And it is used at, yeah, like in here. Oh, I think there's a Java one, I guess. So it's a boolean, and if it is true, it equals to, it would replace the whole statement with this one, and if it is false, if this expression here is false, it would replace this whole expression with only unfolded into BAZ. So that's the same here, just more explicit. If A is larger than B, then this is A. Max of function would return A, else B. Using null values and checking for null. Yeah. Wait a minute. I'm going to take a look at it if I'm live. I forget to check. I've talked for 22 minutes, but I haven't checked yet. Let's see. Yeah, I'm live. Though with no audience, obviously. I don't care. Using null values and checking for null. A reference must be explicitly marked as nullable when no value is possible. So this question mark is when no value is possible. What is this here? 2 strings and they are parsed. So we parse integer into, these are inferred, and parse int returns the integer int question mark or integer question mark, I guess. I think it's a int question mark, although int kinda is the primitive type of Kotlin. using type checks and automatic cast. So if we do something and if we do list instant off, where this is instance off, in Java we most likely would later cast it into that type. So in Kotlin it is automatically cast, so we can directly use the length here when we know the obj is a string. And any seems to be the object in Kotlin, I guess. And unit is void. I need to remember this. Get string length. If object not is, which is just the opposite, not is string, return null. So and here when after this not is, this obj is automatically cast into string. So moreover, oh yeah, if it is used as several compound expression, it is automatically cast too. Using a for loop, we have tried this already. We can use this in. Oh, I don't know this list off. This looks handy. In item.indices, yeah, we have tried this too. And because item.indices is 0, 1, and 2, and this print long here would encounter that item.indices. Where is that? Oh, encounter that index, and so here it is going to be replaced once, twice, and thrice. Is there even that word thrice? And it's very similar in this while loop. I think this is basically the Java while loop. And when is the switch in Kotlin. And so if we use this when obj, we can have a map like when of even different types. So this is really handy. String would be 1, greeting long. Oh, this is even more handy. This is so cool. It's long, not a string, and else is unknown. Using ranges, I think we talked about this, and down to too. Excellent. And we can check range with this in or not in. 0 to the last index. And list.size not in list.indices. That's another range. Yeah, ranges. We can use in against range. This is probably the point. And iterating over a range, of course, and iterating over a range reversely. Yeah, and with a step. Wow, let's just play this, although I know the answer already. Yeah. And collections, item, we can iterate through collections. And we can also use in operator to check in this contains. And using lambda expressions to filter and map collections. Lambda, yeah, so we can filter or map filter these operators. So there are fruits, banana, avocado, apple, and kiwi fruit, and we filter it with only items that start with A, so it becomes avocado and apple, and sorted by, so it becomes P and V, apple, avocado, and map it to uppercase, and so it becomes uppercase apple and uppercase avocado, and for each print long, so it would print in two lines, apple and avocado, all in all caps. And last but not least, so yeah, when we create there is no new in Kotlin, we just simply call a constructor. Just skip the new. Like instead of what you do in Java, just skip the new. And that's 9:30, so that would be the end of the day. We haven't write much answer today, but I think this is a Kotlin packed day. Hope you like it. See you next time.